when it comes to evaluating multivariable limits, another technique you should consider is to multiply top and bottom by the conjugate. So multiply top and bottom by the conjugate of this thing here. So multiply top and bottom by the conjugate. So the conjugate would be this being exactly the same, this being exactly the same, but the only difference is that the conjugate would be a plus rather than a minus. So multiply top and bottom by the conjugate. So this was the technique we used when we were doing single variable calculus. It's the same technique, and it works in multivariable calculus as well. So multiply top and bottom by the conjugate. This thing here, when you multiply by its conjugate, the middle two terms cancel each other out. So this times this would give you x. This times this would give you root x times root y, and then this times this would give you minus root x. This is what I meant by the middle two terms cancel each other out. They cancel each other out, and then this times this would give me positive y. And then here x is in common, x is in common. I'm just going to factor out the x, and remember I'm multiplying top and bottom by the conjugate. So when you multiply top and bottom by the conjugate, this whole thing here will then become this. Okay, the only difference is that I've factored out the x here. So when you multiply top and bottom by the conjugate, that's the conjugate there. That's this thing here. And then get this times this, that will then give you this. So we are now currently here. And then notice that this is exactly the same as this. So these two will cancel each other out, giving you this. Now, as x and y heads towards 0, nothing really breaks down. This doesn't really break down. Square root of x, as you head towards 0, nothing really breaks down. Nothing really breaks down. And then this thing here, it doesn't break down. Square root of y doesn't really break down. So therefore we can conclude that the limit equals 0, because nothing really breaks down here. Okay.